Circuit configuration is the basic physical layout of the circuit. There are two fundamental circuit configurations, point-to-point and multi-point. In practice, most complex computer networks have many circuits, some of which are point-to-point and some of which are multi-point. Point-to-point circuits, which is so named because it goes from one point to another, one computer to another computer. These circuits sometimes are called dedicated circuits because they are dedicated to the use of these two computers. This type of configuration is used when the computers generate enough data to fill the capacity of the communication circuit. When an organization builds a network using point-to-point circuits, each computer has its own circuit running from itself to the other computers. This can get very expensive, particularly if there is some distance between the computers. Let's get into the multi-point circuit. It's also called the shared circuit. In this configuration, many computers are connected on the same circuit. This means that each must share the circuit with the others. The disadvantage is that only one computer can use the circuit at a time. When one computer is sending or receiving data, all others must wait. The advantage of multi-point circuits is that they reduce the amount of cable required and typically use the available communication circuit more efficiently. Imagine the number of circuits that would be required if the network was designed with separate point-to-point circuits. For this reason, multi-point configurations are cheaper than point-to-point circuits. Thus, multi-point circuits typically are used when each computer does not need to continuously use the entire capacity of the circuit or when building point-to-point circuits is too expensive. Wireless circuits are almost always multi-point circuits because multiple computers use the same radio frequencies and must take turns transmitting. Now we're going to get a little bit into the data flow. Now that you know about your circuits, how is that data going to flow through those circuits? Well, actually, there are three ways to transmit. There's a simplex way, there's a half duplex, and a full duplex. Well, let's start with the simplex. The simplex is one-way transmission, such as that with radios and TVs. The half duplex is two-way transmission, but you can transmit in one direction at a time. A half duplex communication link is similar to a walkie-talkie link. Only one computer can transmit at a time. Computers use control signals to negotiate which will send and which will receive data. The amount of time half duplex communication takes to switch between sending and receiving is called the turnaround time. The turnaround time for a specific circuit can be obtained from its technical specifications. Europeans sometimes use the term simple circuit to mean a half duplex circuit. With full duplex transmission, you can transmit in both directions simultaneously with no turnaround time. Well, guess what? How do you choose which data flow method to use? Well, obviously, one factor is the application. If data always needs to flow only in one direction, say from a remote sensor to a host computer, then simplex is probably the best choice. In most cases, however, data must flow in both directions. The initial temptation is to presume that full duplex channel is best. However, each circuit has only so much capacity to carry data. Creating a full duplex circuit means that the available capacity in the circuit is divided, half in one direction and half in the other. In some cases, it makes more sense to build a set of simplex circuits in the same way A set of one-way streets can speed traffic. In other cases, half duplex circuit, a half duplex circuit may work best. For example, terminals connected to mainframes often transmit data to the host, wait for reply, transmit more data, and so on. In a turn-taking process, usually, traffic does not need to flow in both directions simultaneously. Such a traffic pattern is ideally suited to a half duplex circuits. I'm going to talk a little now about the concept of multiplexing. So this gets a little bit more complicated when we're talking about the data flow and how we're going to connect the computers with the cables and in what type of topology. Multiplexing means to break one high-speed physical communication circuit into several lower speed logical circuits so that many different devices can simultaneously use it, but still think that they have their own separate circuits. The multiplexer is technically transparent. It is multiplexing specifically weight lift division, multiplexing, that is, not to confuse you, but that is enabled with almost unbelievable growth in network capacity. Multiplexing often is done in multiples of 4. The primary benefit of multiplexing is to save money by reducing the amount of cable or the number of web network circuits that must be installed. For example, if we did not use multiplexers, we would need to run 4 separate circuits from the clients to the server. If the clients were located close to the server, this would be inexpensive. However, if they were located several miles away from the server, the extra cost could be substantial. So I'm not going to get into the different types of multiplexing because there are several. And since this is an introduction course, I think what's most important is that you know that there are several different ways that the data can flow. Okay? And so, again, we got the simple, we have the half duplex, and we have the multiplexing.